Okay, welcome everybody. This is the IWOCL and SYCLcon 2022 SYCL panel discussion. IWOCL is in its 10th year this year, being held, as you know, as a virtual event. So we're pleased that we're able to have these live sessions that align so we can get lots of you all joining. So thanks everybody for joining today. Very much looking forward to this panel discussion today. So a few little bits of housekeeping before we get over into talking all about SYCL. This is an interactive session. Please do ask your questions. And to submit your questions, please use the Zoom Q&A button. So it's the picture that has two speech bubbles marked Q&A. If you type your questions in there, I'll be putting your questions to the panelists that we have today. Please don't use chat, but you can use chat if you have any logistical or technical issues or questions that you have. So put those in the chat and use the Q&A for asking questions to our panelists today. So Q&A to ask your questions. Please do get typing your questions if you've got a burning one that you would like to ask. It's all about getting your questions asked to these panelists. So please do get involved via the Q&A feature. As you will have seen when you joined, we are recording this webinar and we will post the recording on the IWOCL website as well as link it from the Chronos SYCL page as well. At the end of this session, we're going to have a survey. You'll all be sent a survey as the webinar finishes. And it's really important that you fill that in for us. It helps us make sure that we can do these events better and improve on them for the future. So if you're able to, please do complete the short survey at the end of the session. Finally, just a small announcement. Keep an eye on your emails and your SYCL on the SYCL homepage. We're going to be having a big SYCL questionnaire coming out in due course. Opencl had their questionnaire just a few days ago, and we'll be following that up with the SYCL questionnaire as well. So that's another fantastic opportunity for you to share your experiences and thoughts and give feedback on SYCL. So do keep an eye on that as that is released. Finally, as an announcement, for those of you that haven't seen yet, the revision 5 of SYCL 2020 has been released. So do update your local downloaded copy of the SYCL specification. You can get it, of course, from the Chronos SYCL homepage. The link is there on the slide. Revision 5 contains a lot of small clarifications and corrections and things like that to the SYCL 2020 specification. It is the latest version and is the one that implementers are all working very hard to support. So make sure you check that out. There'll be some comments on that, I'm sure, from the State of the Union keynote as well. That you've all seen as the recording. So do check out the new release of SYCL. And with that, we come to our panel discussion today. So you've been hearing from me. I'm Dr. Tom Deakin. I'm a lecturer in advanced computer systems at the University of Bristol. That's a faculty position. And I'll be chairing the panel discussion today. We're going to ask our panelists to introduce themselves, and we'll go from clockwise around this slide here. So Michael, are you able to turn on your video and introduce yourself?
Yeah, thanks very much, Tom. Welcome to the SYCLcon panel. My name is Michael Wong. Some of you guys already know me. I'm a distinguished engineer with CodePlay, but I'm also the SYCL working group chair. But not only that, within Chronos, I'm also now the AutoSAW council chair. Outside, I was the past CEO of OpenMP, and I'm also involved as a C++ foundation director and directions group. Thank you.
Thanks.
Hi there.
Evan.
Yes, I'm Nevin Lieber. I work at Argonne National Lab. I work on COCOS. That's the main job. I also am I'm the vice chair of the Library Evolution Working Group Incubator in the C++ committee, and I'm also on the SYCL Standardization Committee.
And Roland.
I'm Ron Schultz. I work for Intel. and other than working on SYCL, my background is actually on working on GROMACS.
Thank you. And Verena?
Hello, I'm Verena, and I'm the VP of Safety Engineering at CodePlay. And as part of my job, I'm investigating what it would take for SYCL to run in a car to be used to implement things such as advanced driver assistance features and autonomous driving. And that led to me becoming the co-chair of the SYCL SC Exploratory Forum within Kronos, in which we try to determine what the industry requires from a safety critical version of the SYCL API. And you should all join.
Yeah, thanks, Verena. I'm sure we'll be hearing a little bit more about that later too. Ronan?
Hello, I'm Ronan Keriel and I work at AMD on SYCL and more specifically on porting SYCL on weird platforms such as Fpgas or CGRA. And I'm also the spec editor for the SYCL specification at Kronos, and I participate also to ISO C++.
Thank you. And Axel?
Hi, my name is Axel Alpay. I work for Heidelberg University, where I work on HPC topics and parallel programming models and these kinds of things. And that brought me to SYCL, and I've started the HipSYCL implementation of SYCL, which I now lead as an open source project. And I'm also part of the Kronos SYCL working group.
Thank you very much. So that's our panelists today. I'll turn my video on too, so you can all see me. And with that, please do ask our experts. So use the Zoom Q&A feature to be asking your questions. While we are starting the questions, I have a question that we'll get started with. So SYCL was first released about 7 years ago now, released in 2015 for the first version. So I'd like to ask our panelists, what's the biggest contribution that they think SYCL has made to heterogeneous compute? Who'd like to take that first? Michael, how about you?
Sure, I think that's a good one that I can jump on. So in the world of heterogeneous computing, there's been a lot of great contributions. I think SYCL makes its name among that group in that we have more diverse implementations for extreme heterogeneity, and that's partly because in SYCL 2020 we now enable multiple backends. So it's not just OpenCL anymore. Now you see backends with Vulkan, backends with OpenMP, backends with TBB, backend on HIP, on ROCm. And they're all now even, we're now part of one API. So putting that together, we're now also participating in exascale computing and part of some EPI, European Processor Initiative systems in Europe. We're now part of automotive, part of graphics, safety, RISC-V. We just had SYCL one API with a RISC-V panel at the one API. If that's not diverse for heterogeneous computing, I don't know what is.
Thanks, Michael. Ronan, how about you? You've been involved with SYCL since the beginning. Do you have any comments?
Yes. So of course, it started as an OpenMP, OpenCL higher level model. Sorry, and as Michael said, I think that's what is great in SYCL nowadays is that really an inclusive standard that obviously it's specialized in C++, in modern C++, but besides that, you can really address any device, any platform. And I think the interoperability mode is really an open door to probably any problem you have to get the maximum performance for your platform. Because at the end, if you're using heterogeneous computing, it's just to get the maximum performance of your hardware. So that's a very important thing. So I think we've made quite a lot of progress since 2014. And it's a standard, which means that it's an amazing opportunity to talk with some specialists of the domain And without this participation to the standard, you would never be able to have in your own company so many different people with so many skills. So I think it's a great standard and it works well, and we've I think delivered since 2014. So yeah, let's go on.
Great, thanks, Ronan. Any comments from the other panelists?
Sure, and I think portability is extremely important too. Like I'm an HPC, and our hardware is going to be changing. We know that as years go on, and we need code that's as hardware dependent, but we need performance code, and that's where I think SYCL really shines.
Great, thanks, Nevin. Okay, thanks everybody taking part for your questions. So I'll take some questions from the Q&A and put those to our panelists now. So the first question that we saw come in was, is SYCL well suited for targeting FPGAs for data streaming applications, or is it instead recommended to use Opencl or some other approach for programming FPGAs still? I guess, Ronan, you will put that to you first, please.
Yeah, I think SYCL is well suited for FPGA because it simplifies the code in the sense that it's single source, so you can really optimize both host side and device side. Often we forget about the host side, but it's very important. And when you program, you have to reorganize your data on the FPGA to have better performance, and it has obviously some consequences on the host side too. And also with C++, you can really specialize your code to be more efficient, and you can meta program, unroll some things. So yeah, I don't want to enter too much into optimization here, but modern C++ is very interesting, even to do some very low level stuff and embedded systems. So I think, yeah, it's a good choice.
Yeah, Michael, I think you're on mute still. Michael, are you able to unmute, please?
Thank you. Sorry, second what Renan says, he's got a lot of experience in this because he's been building Tricycle for FPGA, Xilinx FPGA for almost as long as SYCL's been in existence. I want to say that this question is alluding to a kind of a greater question. People always ask, is SYCL more than just GPUs? And the answer is definitely yes. It could be for FPGAs, it could be for neural network chips, any kind of, this is because the reemergence of static data flow and reconfigurable computing, right? There's now chips that are like Samba Nova, Graph Core, Cerebra, and FPGA technologies in general, and the underlying fabrics of all these essential static data flow graph. And in some cases, they operate at clock rates and area efficiencies of custom silicons. And programming this kind of hardware is not easy often, and so it needs new ways of thinking about algorithms and designs. And so, but SYCL actually works very well for a lot of these cases and can work.
Fantastic, thanks, Michael.
And yeah, from Intel perspective, yeah, we also consider like SYCL like the modern solution of how to target FPGAs, and yeah, investing heavily on enabling that.
That's right. So Intel had, the Altera branch of FPGAs, and they definitely are using that on their side.
Which doesn't mean that there's no other tools to program FPGA. Probably if you want to go to the most supported approach, you should use probably some HLS, C++, or tools like that. But I think it's a complementary approach to FPGA programming that will, probably develop more in the next years. I mean, SYCL for FPGA is still a new compared to HLS, which is almost 20-year-old. So we're making progress, and I think it's an interesting approach.
Great. So that's the first question. And I think it's now time to ask questions of our audience. So it's not just a panel discussion where you can ask our panelists questions. We've got some questions to ask you. So we're going to run this via a poll in Zoom. Hopefully you'll be able to see that starting to pop up on your screen now. So the first poll question is all about what SYCL implementations are you using? So please do fill in the poll. So these are the main SYCL implementations as listed on the Chronos web page. So please do fill in the poll. So with that, I think we'll take the next question, which I'm going to ask all about this safety critical side of SYCL. So obviously having safety critical ways of programming things is very important, especially in some domains, as you mentioned, like automotive. So what do you think SYCL needs to do, and what is SYCL doing to address their needs specifically?
Yes, so that is exactly what we're trying to find out. What is it that we need to change in SYCL to make it useful, really useful to those industries, not just automotive, but any kind of safety critical industries, which avionics, for example. I think, I mean, there's a few things that we're pretty sure that need to be changed. So there's things like determinism. So in safety critical, things have to be very deterministic. So that's it has to produce the same output every time, but it also has to compute its output in the same sort of time every time. So that's something that has to be improved in SYCL, because obviously it was never written that way. There's stuff like the API should really conform to a MISRA standard, because that's the guidelines have been written to sort of make C++ code safe in an accepted way. So we think that we're going to have to run a MISRA tools on the SYCL API and perhaps make some changes. And we have to make it more robust as in we have to eliminate those corner cases and the uncertainties and the undefined behavior, and make it really very specific and very clear in all cases. And that also includes the sort of error handling. So in safety critical, it's not just important that you run well, but it also, if you do encounter a problem, that you do the right thing when you do. So there's a lot of error reporting. But these are just some ideas that we came up with so far. And we created this SYCL SC exploratory forum to gather more ideas and to find out specifically also from the industries themselves, what is it that they need? You know, what are the requirements? What are their use cases? Does SYCL SC, even fit? So that's why we're trying to get lots of participation from the industry to help us with that. And I'd also like to point out that we also have an AutoSAR liaison now, a Chronos AutoSAR liaison, where we speak directly to AutoSAR, which is a collection of automotive companies that and they are really interested. I mean, not just in SYCL, but in all sorts of Chronos standards. And through them, we hope that we're going to get a lot of insight as well into what the industry needs.
So I'll add a little bit to that as the AutoSAR council chair that is doing this liaison activity. We've been meeting a month now with various AutoSAR, and soon we'll be bringing in Chronos members for that. And we're already talking about things like how to it goes both ways. We are helping AutoSAR with the acceleration frameworks that we know about. We're experts in that, and they're also helping us at improving our SYCL safety critical. And to that end, people that are attending Verena's safety critical exploratory forum. Probably the biggest thing that I can think of that will come out of that is that both groups will now benefit by accelerating frameworks in automotive and making Chronos framework even more safety critical. Even though Chronos has been involved in safety critical for over 10, 20 years, because there was always OpenGL's safety critical ES that's existed. And now recently, of course, Vulkan and OpenVX safety critical profile and Vulkan SC and things like that. I guess one thing I wanted to point out is once you get into automotive, you're going to get into all kinds of weird, well, not weird, but not necessarily your mainstream processors. And people always are going to ask, can SYCL work on that? And the answer is yes. Students can build SYCL on some weird processors very easily and very quickly. And if your vendor is not using SYCL, it's actually really easy. Either you ask them to use SYCL, and they usually will do it because if a client asks, they will do it. And then they will either come to us and ask us to help build it. There's the SYCL working groups with some members of it, or they will build it themselves. So it's really that easy.
Cool, thanks. I think we'll move on to a new question from the audience. So we have a question that asks, what can SYCL do to lure users who are hesitant to abandon their existing software investment in something like Cuda or HIP or some other proprietary API? Who would like to take that first?
I can give it a start. So first and foremost, I think we should get in touch with those people and see where the concerns actually lie, because maybe it's fairly easy to address those. There are conversion tools, for example, that can convert Cuda code to SYCL code, at least to a large degree automatically to ease the transition. There's in SYCL 2020 backend interoperability, which means that you don't necessarily have to translate your huge code base to SYCL all at once. You can start with one portion and then use the SYCL backend interoperability mechanisms to still have Cuda, for example, in some other portion. With HipSYCL, for example, you can even mix and match Cuda code in your kernel. So if you have an optimized Cuda kernel, you can still continue to use that from SYCL until you're ready to turn everything into SYCL. So I think there's a lot that we can do to actually make the transition fairly easy and smooth and not a huge step. The one thing I think where we need to push more, but I think this is changing, is libraries. So we still have there's one API ecosystem which is growing, where a lot of libraries are accumulating, but there are still gaps. I think this is something that where most of the concern might be coming from. But as I said, I think this is something that's going to be closing fairly quickly as more and more people are using SYCL and find out, okay, I need this library, so I'm just going to build my FFT library, for example, as there's this nice IWOCL talk on SYCL FFT library. So these kinds of things are popping up.
Great, thanks. Anybody else who would like to follow that?
Maybe I'll add a little bit. So first, I would say, of course, this is like a great question actually, like for the audience. So if you have specific things you think we can do extra for people to adopt it, we are very interested to hear about that. And then I think it's not necessary that you have to like abandon your existing investment, right? Like I think we're seeing multiple projects choosing to at least initially use SYCL in parallel to other frameworks, and I think that's a good way to get started, rather than like completely abandoning its existing investment. You can use it in parallel, and then when you're happy with it, that it is portable, you can then choose to use it as your only solution. But that doesn't have to be the first step.
I want to point a second that in that it's the conversion process from Cuda and HIP is not an all or nothing, as Roland is trying to point out. At the U.S. National Labs, they're slowly converting some Cuda code Sickle with if-defs and things like that. I think Nevin can speak to some of that work going on. I saw it last week at the ECP project. Amazingly, some of the work is incremental, which is, and that speaks to it. So some of the works that's being done at these level is actually quite incremental, selecting pieces of it to go to Sickle, testing the water, and then before you go, converting all of it.
Yeah, I mean, I think we all see it. It has to be evolutionary, not revolutionary, right? There has to be a migration, because people can't just start over. I mean, that's not realistic or practical in any projects that we're on.
Great, thanks, Nevin. And with that, actually, I'll building on your word of evolution. Someone has asked, what are the most promising features that Sickle should have next? So looking forward into the future, where do we see Sickle going in the near future and maybe in the longer term?
I mean, near future, like, we're adding complex number support. Thomas Opencl from Argonne pushed that effort. Other big thing we're looking to do is MD-span, which is coming in C++ 23. That has a language dependency, so that may, we haven't decided, even talked about, in the Kronos group, if we're going to require 23 or what that's all going to mean. It's still kind of early days in features. If there's things people, think we need, please let us know.
Yeah, exactly. There are, I think in the survey that Tom mentioned at the beginning, there's going to be a question about some of the vendor and provisional extensions that we've been building in open source GitHub, no less. So you can actually go to the GitHub and look at some of the features we're building, like multi-device queues, command group properties, buffer USMs, pipes, scope parallelism.
And dimension support, more than 3-dimensional support.
Yeah, 3D support, access to property.
That's a big one that at least for our community is very important, and I'm sure for a lot of others as well.
And for machine learning, bfloat 16, things like that are already on some of the Intel GitHubs and Hipsicle GitHubs and the CodePlay GitHubs.
And we also follow ISO C++, which means that you will have even more modern features. And I'm very excited, for example, about ranges. Then you can have an even simpler syntax like Python just in Sickle, so that it will be great, I think.
Yes.
And yeah, from our perspective, we have like multiple extensions. But not just us, like there are also multiple Hipsicle extensions, and I think that's a good place to see what potentially will be in new versions, because the extension mechanism will not. We very much want to like have one Sickle standard, but extension will allow us to experiment, and so things we see work well and users start using. We will try to incorporate into the next Sickle version. So the extensions you find from the different Sickle implementations is a good place where you can check where the different implementers think we might want to add things in the future.
Yeah, I think it's a very important point that a standard is not a magical organization. We just get what you or we put in it. So, and there are probably dozens of Sickle prototypes, open source prototypes nowadays. And so you can contribute. If you have some extension, you can experiment with them and then contact us. And well, it might be in the standard. Yes, good point.
Also, if you have some need for something, and if you feel like there's something that's definitely required, then let us know, and then we can come up with something, or you can come up with something.
Yeah. So what Ronan just said. Yeah, it's you're the people. You know what you want, right? It will. Will certainly help, and we'll see maybe even take it over. But you're the ones with the enthusiasm. At least you got to do the initial push of things you want, because we're doing the initial push of things we think are needed.
Great, that's fantastic. A sort of related question from the audience is saying in OpenCL there's feature has some mechanism for including optional extensions to the standard. Is there a plan to introduce something similar for Sickle? So the example they give is a feature could target some NVIDIA Tensor cores, AMD matrix cores, Intel vector matrix engines with Sickle. So I guess, does Sickle have a plan for these Chronos extensions to the standard?
So we have talked about an extension delivery mechanism. And so, yes, it isn't a plan, but we're still debating about the delivery mechanism. That's not easy. That's probably the thing that we've been, I don't know, maybe other people in here can talk a little bit more about that. I don't know, Renaud, do you remember that delivery mechanism that we were talking about?
So I can comment on it. So
yeah, Roland, yeah, please.
So for I don't know about every other implementation, but yeah, for our implementation, you can query for each extension. There's like a macro. You can query whether the extension is there, and then for device-specific things, the Sickle standard has aspects. So you can like check whether a device supports double or whether it supports half and atomics and so on. So for device-specific things, the Sickle standard has aspects, and for optional for extensions, we have like the extension macros, and then there are also optional features in the Sickle standard, yeah, you can query those too.
Thanks both. That's some great information there. The next question, I think, is an interesting one from the audience is, as panelists, do you see Sickle moving to other languages beyond C++, or do you think Sickle will be purely C++ forever?
So we have periodically gotten people to ask about, can we do this for Python, for Fortran? Here's the thing. Exactly what Devin said. To do that, we need people who are experts in that to make that happen. We're mostly C++ experts here, and we would not do a Sickle Python extension justice or Sickle Fortran extension justice. So that's just the honest truth of it. If there's enough will, there is the possibility, but we're not the right people for doing that.
I think it's actually a fairly interesting research question also, because the Sickle specification has been designed also with what C++ can give us. So we have a fairly tight integration in the interface with modern C++ features. And if we're moving to new C++ standard, then this will only increase. And it's unclear how exactly this is going to map in all cases to a different language. I guess we could probably leverage some of the tech that Sickle implementations have in the back-end side of things, on the runtime side of things. But how the front-end interface exactly is going to look, I think this would be a fairly interesting study to see how Sickle could be mapped to something like Fortran or Python, because I don't think it's totally clear in all cases.
But I think if you have any modern language supporting objects and generic programming, it would be easy to port the basics. For Fortran, well, there is no, I think, generic programming, so it might be difficult. But for Python, it should be really easy to have a prototype, and it's even easier because you have introspection that you do not have that much in C++, for example.
Right. And a lot of it is, we could have, a Python Sickle interface, right? It's how deep does it go, right? And those are really hard questions. I mean, and as Michael said, we're not the Python experts, so we don't know how to answer. We don't know what is wanted, and then how we can figure out how to make it along with Python experts, but we really would need to know, what is meant by other languages.
And of course, what's already possible is that you can use the existing Python C++ bindings to write most of your code in Python and then do the offload with Sickle and bind it with normal Python C++ binding. And yeah, I would completely agree with Nevin that what you want on top of that is really a user question. Like, yeah, if you want more than what normal bindings give you, we need to know what you actually want, and probably, yeah, Python experts on helping with it.
Great, thanks everybody. That's a fantastic question. So it's now your turn. We're going to ask you another question. We've got a new poll for you. The new poll question is going to be asking about where you're using SYCL today. So the question is on what platforms are you deploying your SYCL projects today? So we'll just get that poll question up for you to answer. And in the meantime, someone's asked a question directly to Axel. So I'd like to put that to you. It asks about the motivation behind creating HipSYCL. And they say in future, AMD and NVIDIA might support SYCL on their own. And they're suggesting it might be much faster in terms of performance if it comes from a vendor. So what's your reaction to that question?
Okay, that's of course a bit of a provocative question, but maybe let's start with the motivation behind HipSYCL. Originally, HipSYCL, what people forget is that HipSYCL is a project that already started in 2018, and back then SYCL was tied very much to OpenCL, and the SYCL ecosystem on GPUs beyond Intel GPUs did not look very good. So HipSYCL, when it first came around, it paved the way to actually run SYCL well on AMD and NVIDIA GPUs. Nowadays, it has turned into a full-fledged and very mature research platform that we use to tackle all sorts of questions. And it's by no means limited to AMD and NVIDIA. We also target CPUs, including compiler acceleration. So this means we can run efficiently on Intel, AMD, ARM, Power, whatever you want. And we are also adding support for Intel GPUs. Even if AMD and NVIDIA were now to start adding support for SYCL on their own, we basically have a head start of 4 years. It's a very mature platform by now. And we are also, in many cases, so the design of HipSYCL is based on the idea that we can actually tie into tool chains that AMD and NVIDIA already provide, which means that in many cases, we're already using the exact same compiler backends that they are using. And in some cases, we can even use the exact same compiler front ends that they are using. For example, on NVIDIA, we can run as a library for NVC++, which means that the exact same thing happens as if you compile Cuda code with NVC++, except that you have the SYCL C++ interface. On AMD, we can run with their Hipclang compiler as code generating backend. So I think the assumption that magically NVIDIA and AMD supporting SYCL by themselves would make things faster is probably not true. And you can also see this in many studies that have been done, that HipSYCL actually performs very well compared to Cuda code or Hip code. So I think it's not very realistic to expect a magical significant performance gain just because NVIDIA or AMD are pushing SYCL by themselves.
Great, thanks, Axel. That's hopefully that's answered your question. Then hopefully you're all filling in the poll on your platforms that you're deploying SYCL. Please fill that in. It'll be great to see what all your answers are. The next question, I think, coming in from the audience that I'd like to do is again about implementations. So from the audience, when should we expect to see the first conformance SYCL 2020 implementation, or even better, implementations? That's a question from the audience there. Michael, do you want to start first with that, perhaps?
So the question is about when can we see the first SYCL 2020 conformant implementation. So a little bit about Chronos process. Chronos languages requires conformance tests and adoption. And so with that, we are now working very hard on SYCL conformance tests. But because of recent global events, we've had to head towards a direction where we set a plan for an RFP for this for building this conformance test, in such a way that we can expect a minimal viable product by the end of this year, maybe early this year. So I would say SYCL 2020 conformance will happen, but it will happen after this minimal viable product for RFP occurs for SYCL. Now that plan was just sort of laid out in the last couple of months, we have some budget to make that happen, and so that's where we think that that's probably one of the best direction we can head to getting conformance as fast as possible.
Thanks, Michael. Would any of the implementers like to talk a little bit about their plans for that? I'll open the question. How are the SYCL 2020 features going as you're implementing them in your implementations? So perhaps Roland, you can talk a little bit about DPC++. How's SYCL 2020 going?
Yeah. So we have multiple of the SYCL 2020 features implemented, with each of the DPC++ releases. We will add further ones. I just didn't answer the initial question. We don't quite promise yet exactly when we have all implemented, but yes, we're working hard on implementing more and more with each release. And of course, if you have specific features which we're still missing and you need, please give us feedback on any channel, including like our GitHub. You can tell us which features are particularly important.
Thanks. And Axel, how about in HipSYCL? How's SYCL 2020 going so far?
Like DPC++, we already have implemented many features, including, I think, most of the major features. So if you want to use the biggies from SYCL 2020, like USM or group algorithms or so, then we've got you covered. I think there are a lot of details that still need to fix, that still need some attention to fix, like the exact interface of some queries that have changed. And so like the smaller things that require a lot of attention and going step by step and a lot of detail through the specification, this will take some more time because it's very easy to miss things. And yeah, I cannot give you a definite date when this will be the case, because we're in parallel also working on improving performance, stability, usability, these kinds of things as well. But yeah, if you have a specific feature that you need, then please let us know, and then we can take it into account when we are prioritizing things.
Thanks. And CodePlay obviously has a compute CPP. Would one of the panelists from CodePlay like to talk about how SYCL is going?
Yeah, I mean, I can really, it's going to be an echo of what all the other panelists said. We recently released Compute CPP 2.10, and we've already got quite a lot of the 2020 features implemented, including USM and unnamed lambdas. And we have an internal roadmap towards conformance, but that varies, depending on what's going to be happening in the next few months. So don't really want to put a definite date on that.
That's great. Thanks very much. Okay, a follow-up, I think, to Roland has volunteered to answer this, but I'll ask it live. Is the SYCL API standardized and used by all SYCL implementations? And obviously, implementations can have their own extensions. So can you talk a bit about the deviation from SYCL in things? Yeah, so I think I mostly already answered that when it came to like the extension question earlier. But yeah, so to just recap, the
We are publishing a lot of extensions to explore the space of where extra things are needed, but we're very much committed to SYCL being a standard which is portable. So for all of the extensions which are broadly useful, so not some like targeting some very specific thing of our hardware or something like this, and are seeing usage, so are successful in that they actually like help users. We plan to get them all into the standard. They might of course change when being standardized with the feedback of all the other implementers, and that's why when you make use of an extension now, it's in its own namespace, so that when it becomes standardized later, the API might change slightly, and then you have it in the standard namespace. But yes, we want all of the portable, useful things to be standardized.
That's great. Thanks very much. Changing topic a little bit, we've had a question come in asking about AI and machine learning. So where should AI and machine learning developers be looking to make SYCL part of their toolkit? So should they be looking at all? And if they do, where should they start?
Okay. It is definitely one of the things that we can do with AI. There was a kind of a related question earlier about, MLIR. And this is one of the things that there's a growing need for higher level abstractions for device kernels in heterogeneous environments. And the multi-level nature of MLIR infrastructure perfectly addresses this. So Huawei has built a SYCL over an MLIR. And the way it's primarily a converter. It's capable of translating SYCL specific LLVM IR to MLIR. And what that does, what happens is that this allows for both target and application specific optimizations within the same framework to exploit opportunities for improvements at different levels. So that's one way. The other one, of course, is building it directly over top of some neural network chips. And we definitely have been exploring with various neural network hardware vendors to work with that. So far, I have to say that a lot of neural network vendors tend to want to build using their own tooling. They don't really see open standards as something that they need to do yet. And honestly speaking, in my 20, 30 years in this industry, I've seen people do that early on. They kind of want to keep it siloed. And no fault to anybody, that's just the way people think. But after a while, the need for a more open standards that can work across different units of the same kinds of chips will start to emerge, I believe.
Thanks, Michael. And a related question that I was going to follow up with is, what about as a user, maybe they don't want to write SYCL directly, but use some machine learning framework like PyTorch or TensorFlow. Do you know anything about how those frameworks are thinking about SYCL?
I do. We've actually have translated TensorFlow to using SYCL. We contribute to the TensorFlow board on these things. So, and PyTorch is also using it, though they're using it mostly through MKL, through one API right now. So the pattern is emerging on the popular frameworks. And we often say, because most of the big machine learning frameworks are written using C++ templates, they make actually ideal candidates for converting to SYCL. This is exactly the audience we're going after. And so there's nothing wrong with convert, and if it's not there, convert it. If it's there, you can just directly use it. And now you can, through the magic of SYCL heterogeneous multiple paths, you can now convert it to whatever different kinds of chips that you might want, instead of most of them were written primarily for just one chip. That's the real difference here.
Great, thanks, Michael.
Mm-hmm.
Okay, a new question from the audience is asking about some existing code. We had some question earlier about what if I've got existing code in Cuda or HIP. this question is, what about if I had existing code in OpenCL? So does it make sense to translate OpenCL kernels to SYCL, or is it better to keep them as they are and integrate them into the SYCL environment? And is there a performance issue or any other issues that we can foresee there?
So the interoperability allows you to take OpenCL kernel as is and run them in SYCL. And if you already have existing OpenCL kernel, that's a great way of getting started. There is now, I think, with multiple of the vendors who support SYCL, like a lot of effort currently in SYCL. So we have like some extensions which are only in SYCL, so you can make only use of them if you convert them. And so as I mentioned at the beginning, I'm involved with the Gromex project. They had OpenCL kernels, but we decided to experiment with it at the beginning. There, we did use the interoperability, but then quickly we did convert them to make use of extra features. So I think in general, that's what I would recommend.
Also, maybe to add, the SYCL world is now actually larger than the OpenCL world. So if you keep your kernels in OpenCL, then you can run on OpenCL devices, of course. But if you translate them to SYCL, you can run them on OpenCL devices. You can run them on pretty much any CPU. You can run them on HIP, Cuda, whatever. So actually, there might be a portability advantage by just translating the kernel to SYCL.
Great. So there's a way forward in the short term, and then maybe a longer term goal there. That's great. There's a question here about SYCL and C++. There's a couple of questions coming together about that. So one question is saying there's the standard execution proposed in P2300 for C++23 or beyond. How do we see this proposal working with SYCL? And that's a specific example, but a more general question that came in a little earlier was that apparently this question says that NVIDIA says SYCL is a dead-end path and ISO C++ is the only real standards-based solution for heterogeneous programming. So why should we use SYCL instead of pure C++? So really, I'd like to open the question out. What do we think about SYCL and C++ and the relationship between them now and in the future? And Nevin, why don't you
I'm not quite sure that's an accurate representation of what my friends at NVIDIA have said, right? Right, C++ itself really doesn't support much in the way of heterogeneous computing. I mean, and I'm pretty sure if they've publicly said that's the same thing, right? They're just pushing for and our ultimate goal of SYCL is to get a lot of the, how much of this stuff can we eventually get into the C++ standard, right? So that everyone can leverage it, and it's hard, right? That's decades in the making, and I'm not exaggerating. Even things like I know someone mentioned P2300 standard execution, right? That is not making C++23, right? Centers and receivers is hopefully we'll make C++26. That's our current goal. There was too much churn. We could not make it happen for C++23. I mean, again, NVIDIA is a vendor, right? They're trying to sell their chips. There's nothing wrong with that, right? They want to sell their platform, right? We see, SYCL, we see more portability, right? Right now, how much can we do, in just a library implementation of SYCL? And, maybe do we need language extensions? We've had language extensions in the past, like, unnamed lambdas, we need tool support for. And we're going to keep doing that. But our goal, I think, is to get a lot of, see how much of the stuff we can finally get into C++ proper, right? We're kind of more the playground of like, we flesh out these ideas and, find out, what works across a wide variety of hardware, because that's what the C++ committee is concerned about, is a wide variety of hardware. They don't have the time and the resources and the expertise to do little niche things, right? They want things that have broad appeal. When I put my C++ committee hat on, right? You want things of broad appeal.
I think what is important for SYCL is inclusion. We need to address any kind of hardware, while C++, well, you assume there is this magical memory models, and you have some very complex and power-hungry hardware running. But in SYCL, we need to address the little bit of your silicon everywhere. And that means, for example, if you have a very specific hardware operation on your system, which is exposed, for example, as a built-in kernels, we can call it in SYCL, while it doesn't have any meaning in the C++ world. So I think that people selling that the idea that C++ is enough. Well, it's enough if you can spend a lot of power, consumption, electricity to just run these huge infrastructures to run C++. But it's all about inclusion. What do we do with all the hardware on Earth?
Remember, C++ doesn't even have a notion of multiple processes running on the same, CPU, right? Let alone heterogeneous computing. And it's really hard putting those abstractions in. I mean, and even things like NVIDIA, they have language extensions for their hardware, right? Some of which are more general, and I hope eventually get proposed to things like standard C++. But they're not doing a pure C++.
So maybe to make it more concrete, I think this question refers to NVC++ parallel STL offloading for GPUs. And if you compare this with what SYCL has to offer today, you will find that with SYCL you can get a lot of control over your kernels and how they're executed on a vast array of hardware. Whereas with what NVC++ offers, you can have some STL algorithms that do only expose a fraction of that control that you have. I mean, there's no way, for example, to utilize local memory or something like that when you use that on NVIDIA chips at the moment. And I don't think that's a comparison that really stacks up to each other.
Right. I think everybody said it best. Roland, did you want to add more to it? I think you wanted to answer.
Yeah, I think most points have been made, but yeah, I think the combination of those last points, I think, is the key to us. So Nevin laid out the difficulties of getting it into the standard, and many SYCL members are working with standardization. So it's not really so much a competition, because we also work with the ISO standard, but yeah, the ISO standardization process is very slow. I think that's fair to say. And that's not a criticism. That's just it's just
reality. Yeah,
exactly. And so we won't have even the basic execution until the earliest 26, and then, as was pointed out, to actually have control, which is important for performance, which is like shared local memory. And some kind of what we call subgroup, and NVIDIA calls warps primitives. So you need multiple different ways of actually talking to the hardware in a parallel way, which we enabled with SYCL, with subgroups, to actually get performance. And until all those things are also in ISO, and most of those aren't even proposed yet, yes, you can execute heterogeneously, but you won't get performance for any non-trivial kernel. So there will be a pretty long process until you actually can get portable performance with ISO. So if you can wait that long, yes, you can use it, but at the moment, that's not really an alternative.
Yeah, and on the C++ side of things, like MD-SPAN, right? There are people from NVIDIA who also worked on that, because we found common ground as something we want standardized. And I expect that to continue, that kind of thing. Both, certainly within SYCL, we want to do that, and certainly, we want all the vendors to get on board with things we're doing.
So this is really a good place to settle that question. That question has been brought up a lot, and some of it is obviously, a little bit of hype, and so People have brought up the issue with time, how long it takes, some missing features, the fact that even, you might need to do local and that's not there yet. And I'll just answer, I'm not going to repeat everything here, but you've gotten a good answer from all these experts on the panel, probably the best I've seen. I will say something about 2300 execution. Yes, we plan to follow that. We've been active contributors of that. So have Intel, so have Nevin and other people. So when it does come out in a form that is suitable for our consumption, we will definitely follow that.
Yeah, we'll help shape it, and we plan on consuming it.
Mm-hmm.
Thanks, everybody. That's really great. So we are running just up to the top of the hour, but I think there's still a few more questions. So I think we're going to overrun for a little while, thanks to the panelists that are able to stay a little bit over time. So as a prize for us for going longer, hopefully you'll be able to answer our third poll question. So we'll pop that up for you in a moment. This is really an interesting question. So where do you, as users of SYCL, people writing SYCL applications, go for SYCL support? So how do you ask questions when you need help writing SYCL? Is it Stack Overflow or a forum, or do you just email your friendly local SYCL implementer directly? Really interested to see the answers to this. We're going to try and put the poll results together into a slide that I'll share at the end. So we should see that very shortly. So please do answer the poll. Thanks for your contribution so far. Okay, a question from the audience next that I'm going to start off by putting to Axel, if that's okay. And it says, what would be the best way to express nested parallelism and algorithm composition in SYCL? So there's sort of two questions here: nested parallelism and algorithm composition. The algorithm composition, they give an example of, say, standard transform and standard reduce. You can put together as transform reduce. What is the goal of SYCL? To go towards this nested parallelism and algorithm composition.
So there's nested parallelism. There are a lot of different meanings what this can refer to. So this could either be something like what Cuda calls, I think, dynamic parallelism, where you launch a kernel from another kernel, or it could be something like a hierarchical approach, which we had in SYCL 1-to-1 with SYCL 1-to-1 hierarchical parallelism. And regarding this, HipSYCL has an extension that we are proposing for a future SYCL standard called scope parallelism, which kind of generalizes this approach. Or it could mean something like approaches that you have in maybe TBB, where you have a more tasking-based approach, and then you're launching a lot of other tasks from your tasks and build some kind of task graph. And we have done some experiments with that on CPU. So there are some ways in which HipSYCL also can support this use case. And I'm not sure what exactly this question refers to exactly here with regards to the nested parallelism. And for the algorithmic composition, well, in the end, SYCL is just C++, right? So I'm not sure if we need to do anything in addition to what you can already do in C++. So I'm also not exactly sure what the target here is. Maybe the other panelists can help out.
Axel. Roland, I think you said you were interested in answering this.
Yeah, I think it's there are interesting research questions in this space, or explorative. Like Axel mentioned, he has a proposal for nested or scope parallelism. We are also exploring a couple of options. And when it comes to the algorithmic composition, I think there are interesting ideas regarding how much you can do this automatically with compiler optimization. That you can like write multiple algorithms and they get inlined in effect so that they get executed together. But I think we are not. The moment we're not ready to like have anything in the SYCL standard. So I think this is a good space where for experiments, either as form of extensions or as form as third-party libraries. And then when we find things which really work well, we can then put them in the standard.
That's great. Any other comments from the other panelists?
Comment is that Yanis is from AMD, so just come to the SYCL committee and participate to the discussion to push your ideas.
You are a member. We love to see a contribution towards that direction, composition.
Okay, and I think with that, we've come about to the end of the panel discussion. I'd like to extend a very heartfelt thanks to all the panelists. Thank you for joining us today. Thanks for staying over time. Thank you to all our fantastic questions from the audience. You've really put our panelists through their paces, which is what we like to see on these panel discussions. So with that, I will just start sharing the presentation just as a quick wrap up. If all the panelists could just turn their video off, I'll do that as well, just so that we capture this part of the thing for the recording that will come out later. Thanks, everybody. I'll do myself. There we are. So we've asked our experts and they've all given us our responses. So this is the responses from you. This is the poll results. So I'll just show these up here. So the first question was, which SYCL implementations are you using? Lots of people have responded to this. I guess the Compute CPP, DP, C++, and HipSYCL are the main ones, but good to see people trying other ones too. For those of you that have not tried a SYCL implementation, I would encourage you to learn SYCL. There's some great resources for that on available through the sycl.tech website. That's the URL, sycl.tech, and some fantastic learning opportunities there. And as part of IWOCL, there was a number of SYCL tutorials too. So hopefully you'll be able to answer with one of the other responses next time we ask this poll question. The second question was about what platforms you deploy on your SYCL, projects on. Heavily skewed here to supercomputers and desktop, about an equal split between those two. That's very interesting with some embedded and mobile too. So thanks everybody for answering all these polls. It's very interesting to have the results and it's nice to share them with you too. And finally, SYCL support. Where do you go for support? To your friendly neighborhood SYCL implementer, or maybe Stack Overflow or a forum. That's very interesting. I think there's some discussions that we will have with the Chronos Working Group about the best way that we can think about supporting SYCL, and hopefully have those discussions with the implementers too, to make it a little bit more scalable. So thank you very much for your honest feedback on those polls. That's very interesting indeed. So finally, thanks again for attending this session. We're going to end very shortly. This has been the IWOCL SYCLcon SYCL panel discussion. And please do check out the rest of the IWOCL and SYCLcon program. As you know, that's all through iwocl.org. There's a huge amount of pre-recorded videos from talks. A large number of them this year are all about SYCL. So do take the time out of your busy schedules to catch up on all those contributions to IWOCL and SYCLcon. I'm very much looking forward to catching up on them, and the ones I've seen so far have been really great contributions. So do check that out. And please continue to use the Slack that's been set up for this conference, the IWOCL SYCLcon Slack channel, to continue the conversation. Most of the panelists are all on Slack too, so you're able to get in touch with them directly that way as well. So keep an eye on the IWOCL website. The recording for this session will go up there too. So with that, I'll end the session and hand over to Jeff, who I think has got just a short message.
Before you do, thank you very much, Tom, for leading us, herding us cats. That was fantastic.
Thanks, Michael.
Yes, thanks, Tom, and thanks, Michael, and thanks to all the panelists today. We appreciate your effort and your time. As a reminder, recording of this presentation will be available on the IWOCL and Kronos Group websites in the near future. As you leave the webinar, please take a moment to fill out the survey that pops up. Your feedback is important to us. Thank you for joining us. We hope you enjoyed this session and have a great day.